Welcome, future elementary educators. In this screencast, we look at the area of a circle. Now, there's a part of your textbook that talks about the area of a circle, and they give their reason for why the area of a circle is what the area of a circle is. I have a slightly different reason why the area of a circle is what an area of a circle is, and it boils down to this question that appeared on a state exam in a geometry course several years ago. Pause for a moment, see if you can identify what's going on. So what's the basic idea here? The basic idea here is we take this shape that's round that we don't know what the area of it is, and we turn it into something that's basically a rectangle. It's basically a rectangle, and we know how to find the area of a rectangle. The area of a rectangle is its base times its height, its length times its width, you name it. So what's the height of the rectangle? Well, the height of the rectangle is the same as the radius of any of these sectors. This is the height of the rectangle. So then the question comes, where is x? Where does x come from? Well, x is this little thing and 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 so on. So this is this little thing and 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 so on around the thing. So right about there, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is x. But wait a minute, x, that's half the circumference of a circle. Well, the circumference of a circle is 2 pi times its radius. So x is 1 pi times its radius. This is 1 pi times its radius. And so the area of a circle is base height, length times width, x times r, pi r squared. That's the area of a circle. We take something that's round and we turn it into something whose area we know how to find. Yes, it's not exactly a rectangle. Yes, you kind of have to squint to see that the length is straight and the width is straight. But if we broke it up into some smaller sectors, maybe we did 2,400 congruent sectors, these would basically be straight. This would basically be straight. The more sectors we break this up into, the closer it comes to an actual rectangle. So we don't worry about the fact that it's not exactly a rectangle because we're not using 24 sectors, we're using a whole bunch. So this makes us able to take a circle with a diameter, with a radius of 5 inches. We can find its perimeter. We can find its area. Perimeter is called circumference. When it comes to circles, the circumference is 2 pi r, or if you like, pi d. I like 2 pi r because we know what r is, and that's 10 pi inches. Notice, circumference is one-dimensional, we get inches. Area, that's pi r squared, that's pi times 5 squared, that's 25 pi square inches. Notice that area is two-dimensional. It's two-dimensional. We get square inches. That's how we know that our units work. Area is two-dimensional. It requires a two-dimensional unit. Circumference is one-dimensional. It requires a one-dimensional unit, and that's kind of how you keep them straight. So we can do more like this. I have several examples set up in another screencast that we'll do right after this.